counting the number of set bits. It is interesting question. How to count a number of set bits? Let us take 50. What's the binary equivalent of 50? I wrote here. Yes, 11 11 00 10. Let us take it 11 00 10. So this is the binary representation of 50, right? Now I want to count how many set bits are there. See here, this is one set bit, second set bit, third set bit. So that the output will be 3, right? So my output will be 3. So how to approach this question? How to make a concept for this? Just see here. I will take first of all 11 00 10. I will check whether this last bit is a set bit. No, right? No. Now I will move this bit 1. I will shift this bit 1 upon a right side. 1 upon right side. Now I am going to check this whether the last bit is set bit. Yes. Update the result. Now again shift 1 ahead in right side. Check for least significant bit. Whether this is a set bit? No. Again do. Again check whether it is a set bit. No. Again do. Whether this is a set bit? Yes. Update. Again shift. So now there is only one element. It is one. Update. Now again shift. It will be 0. So here we want to stop. So what is the code for it? So I will be doing this stuff when the element is greater than 0, and I want to extract last element. I want to extract the last element, so that if n and 1 is equal to 0, equal to 1, then I have to count it. Right? Then I have to shift n by 1. That's all. What's difficulty in this problem, right? So this is what the counting of set bit, right? So see here, I go to the question. Yeah, fine. Now we can also do like, we don't want to reduce the num to 0. We want num as 50, but I can use another variable I. Okay, I am using the another variable I is equal to 1, and when I am shifting num by I times, it won't give a 0. Then I can go and loop this loop. Okay, then I will go and iterate this loop. Nums and I left shift, 1 left shift I times is not equal to 0. That means take for example, I can also explain this approach. Just take, wait, I can scroll it. Fine. Now take this approach. Same number 1 1 0 0 1 0. Now I am taking a variable I. Initially it's at 1. Shifting this number 1 step right side will give me any 0. No, right? No. Now I am going to use this value. Now take this value 1 1 0 0 1 0, and initially take I is 0. I written wrong. Here I is 0, because we want to see, we want to check the first bit also, right? For this bit, also we want to check. But initially we want to right shift this. Right shifting upon 0 times, it is same number. So condition is not false. It is true. Now this number I 1 left shift 0 time, it will be 1. So doing AND operation, it gives me what? Oh no, using AND operation, it will be all zeros, right? So it will be 0 result 0. So it is not a set bit. Now I update my IS 1. Now again right shift this value with 1. It will be like 1 1 0 0 1, right? Now again take this same value. It is greater than 0, right? So the condition is not false. Now take this value again, do with what? 1 0, because 1 by I, which is 1, equivalent to 1. So 1 is left shift with 1. So 1 0 0 0 0 1 0, right? So doing this, we get 0 1 0 0 0 0. So it is not equal to 0, right? It is not equal to 0. It is equivalent to 2. So it is not equal to 0. So we can count result as 1. So my result is 1, right? Right? Now again I will be 2, again I will be 3. So do that stuff in your own way and try run this code. Fine. This is the approach. This is the approach. Let us take the code. So this is the approach, right? Now multiplying and dividing by 2. As we already we have seen that when we are using that mod 2, mathematically mod 2 is equal to bitwise and 1. We have already seen that, right? That is mod 2, n mod 2 is equal to n and 1, right? We have already seen that. It is math, it is bit, right? Like that we can say n into 2 is equal to n right shift 1. N into, divided by 2 is equal to n right shift 1. This is left shift 1, this is right shift 1, right? So these are the expression. This is math, this is bit, right? So these two are equivalents. Now how this come true? How this two come true? Because take for example maybe 5. What is the binary representation of 5? 0 1 0 1. Fine. Now when I am doing 5 into 2, it is 10, right? When I am doing 0 1 0 1, left shift 1, it gives me a result as 1 0 1 0. Fine. So it is equivalent to 10. Understood? So this is the representation of n into 2. Now n divided by 2. Let us take the same 10 and 5 example. 10 is 1 0 1 0, and when I am doing divided by 2, it gives me 5, which is 0 1 0 1, right? Now 1 0 1 0, right shift one time, it gives me 1 0 1, right, which is equivalent to 5. So this is the way we will do in math and do in bit manipulation. Now till here it is fine. Now tell me about this. What will be my answer? I can say this is equivalent to n divided by 2 power 2. This is equivalent to n divided by 2 power 4. So which is equivalent to n by 4, and it is equal to n by what? 16. Fine. So take the same and do a left shift. Now say n into 2 power 2. It is n into 2 power 4, which is equal to n into 4. Here n into 16, right? So this is how. Always remember, right shift is division of 2 power n, and left shift is multiplication of 2 power n. Fine. This is the proof how the right shift is working as a division and left shift working as a multiplication. Fine. Now let us see the next concept. XOR operation. So this XOR operation is very much important because XORing two same value gives me result as 0. XORing any number with 0 will result in any number, right? Now just see here. Take for example, I have a number called x. X XOR x is equal to what? 0. X XOR 0 is equal to x, right? So I can conclude that if I take 10 XOR 10 is equal to 0, and 10 XOR 0 is equal to 0, 10, right? Okay, fine. Let me take another example. 10 XOR 10 XOR 10. What is my result? First, when I am doing this 2, it will be 0, right? It will be 0 XOR 10, which is equal to 10. Fine. Now 10 XOR 10 XOR 10 XOR 10. First I am doing this 2. it will be 0 XOR 10 XOR 10 is equal to, then I am doing this two XORs, 10 XOR 10, then I am doing this 2 is 0. So I can conclude that whenever I am doing, there are same numbers, take for, it is n number of same numbers, let us take n number of 10. Okay, when it is even, when it is odd, when the number of elements is even and I am doing XOR, it results in 0. Fine. When the number x is occurring n times, the n is odd, the result is x. Right? So these are the concept. I make sure you want to clear in this concept. Right? See here, print num XOR 10 and num XOR 0, 0, 10, right? 10 XOR 10 XOR 10, it gives 10. Let me take another XOR and put 10. Now it result in 0 because it is even number, right? Even number of occurrence. Now XOR can be used as a toggle operator. Take for example, in some problems they want us to take alternative sequence, like if I am iterating a loop, maybe a for loop 0 1 2 3 4 5, at 0 some number x should be 0, at 1 the number should be 1, at again 0 and again 1, again 0, again 1. This is my alternating sequence, right? For this initially we keep x is 0 and make XOR 1 is equal to 1, another time XOR 1 is equal to 0, another time XOR 1 is equal to what? 1, another time XOR 1 it is 0, another time XOR 1 is 1. See here, the results are initially it is 0, then 1, again it is 0, then 1, again it is 0 and 1. Okay, it is alternating in nature, right? So it is a toggle operator. XOR is used as a toggle operator by using the 1. Fine. So that's what I have written here. See here, I is less than 3, print num is equal to num XOR 1. So initially num is 1, then 0, then 1, like that. It is go alternating 0 1 0 1 0 1, right? Now the next concept is swapping two variables without using a temporary variable. We want to do this with using XOR operator. Let us see how to do this. Just see here, I have two numbers. Let us take 5 and a number is 10. The binary representation of 5 is 0 1 0 1 and binary representation of 10 is 1 0 1 0. Fine. To do this, we first want to do A is equal to A XOR B. What is the A XOR B? 1 1 1 1. Okay, so A XOR B is 15 and in A 15 is stored. Again now store B is equal to A XOR B. So what is in B? It is 10, right? So 1 0 1 0. So what is my XOR value? It is 1, here 0, here it is again 1, here it is 0. Now my B value is 5. Right? I have swapped successfully A to B. Now I have to do B value to A, right? How to do this? A is equal to A XOR B. A value is 15, B value is 5. The resultant will be 10, right? So at last my A value will be 10 and B value will be 5. So I successfully swapped the two numbers without using temporary variable. Okay, so this is the way we have to swap, and be conscious with this concept. Fine. Let us see the solution. See here, A is equal to 10, B is equal to 5, A is equal to A XOR B, B is equal to A XOR B, then B is equal to A XOR B. No, it is A. Okay, because A should contain the value of B, right?